Hello friends, welcome you all to the next lecture of the JC Connect series of online lectures. We are into module 4 and dealing with the topic Centroid. Let's come to the next example. Okay, now these are second type of examples which we call it as cutout sections. Okay, now in this examples what is difference is you might see this figure, okay, which is shaded, and there is a small circle in between. Okay, that small circle represents a cutout section, okay, which is not a part, it has to be subtracted. If you have done some craft or those things from a big card sheet, we used to cut out the sections of the required shape. Okay, so here also these are similar concept examples where from a given area one part is cut out. Okay, so procedure remains the same, that is, when you observe the figure, we have a semicircle, we have a rectangle, and we have a small circle, but that small circle is not shaded. Why? It is a cutout section, means from this entire area we are removing that small circular section. Hence the only change which comes up in these problems is the area of the circle. When you consider, it should be taken with the minus sign. Okay, again I'll repeat, that small circle we are cutting it out from the entire area. So what thing we have to do is we have to take that circular area with a minus sign because it is cut out. It is not taken into consideration, but it is existing in the figure. That circle is existing in the figure. So we have to take its area but with a minus sign. You need not change the sign of x and y, they will remain the same. Only the area of the circle, which will be our third element, it has to be taken with a minus sign. Then the next fix or the next trick in this example is, when we look at this example we feel it is symmetrical. Okay, symmetrical means if we cut it vertically, left and right will be the same. Yes, 90% of the figure is symmetrical, but see that the circle is not lying at the center of the figure. Okay, the circle will not lie exactly along the vertical centroidal axis, because when we see the base depth, okay, that is 400. Now see the marking here. Okay, how much is the gap of the circle? From the face it is 150. How much is the diameter given? 50. Okay, that means it is 200. Beyond the circle 200 is remaining. If it was a symmetrical figure, half circle will lie on one side, half circle will lie on another side. But now in this case this circular hole is not symmetrical because it is lying in what length? 200. 150 plus 50 is the diameter. Okay, if it was symmetrical it would have been exactly at the center, that is half circle on one side, that is 200 width, half circle on the other side, that is 200 width. But here 200 we get after covering the circle. So remember, this circle is not exactly symmetrical with respect to the vertical centroidal axis, but our semicircle and rectangle will be symmetrical. So x1 and x2 directly will be 200. Okay, need not break your head for x1 and x2. Only what we'll have to find is properly x3, and then we have to find regularly y1, y2 and y3. Okay, so hopefully I have properly highlighted what is the difference in this example. It is a cutout section firstly, and secondly it seems to be a symmetrical figure, okay, with respect to the vertical centroidal axis, but the position of the circle is such that it is not exactly symmetrical. But secondly, your semicircle and rectangle can be taken as symmetrical element, and directly we can take x1 and x2 as 400 by 2, that is 200. Okay, so now let's start with the example. Here we have clearly three well defined figures. One is a semicircle, one is a rectangle, and one is the hole, circular hole, which is cut out through the rectangle. So let's start with the analysis. So we have three figures. First I have taken the rectangular element. I'll zoom it for you all. Okay. So my rectangle is of area 400 by 500. For this your x value can be taken directly and y value is as shown. I think I have just messed up with y1 y2 marking. It won't make a mistake, just take it correctly when you further go for the table. Okay, I apologize for that. Just y2 and y1 I think I have interchanged while writing. So for rectangle it is y1 and for the semicircle which we'll discuss next it will be y2. Please do the correction while solving the example. So here y2 will be clearly defined. Y2 is half of the depth, that is d by 2, that is 500 by 2, because the rectangle itself lies on x-axis. So directly we'll get y1 as d by 2 and x1 as I told will be 400 by 2, that is 200. Now next we'll come to the semicircle, which is the topmost element. Okay, so here I'll be taking y2. Again I apologize for this writing mistake. Okay, please make it y2 while solving. Now how much will be y2? Firstly, coming from the CG to the base of the semicircle will be 4r by 3 pi. Then beyond the base of the semicircle up to the axis it is 500. So my marking will be y1 is equal to 4r by 3 pi, which is the centroidal distance of the semicircle from the base of the semicircle itself, plus to that I have to add 500 to reach the x-axis. So my y2 value will be 4r by 3 pi plus 500, and as explained earlier x2 will be directly 400 by 2, that is 200. Now comes the next figure, which is our cutout section. Okay, so what will be my value of x3? x3 will be 150 because we have to add from the axis 150 plus r, or half the diameter, because the center of the circle, at the center of the circle if we take from any edge it will be d by 2, which is nothing but the radius. So my x3 will be 150 plus r, that is nothing but 150 plus 50 divided by 2, because 50 is the diameter and radius will be half of the diameter. Then last element is y3. If you observe the figure carefully, directly that is given in the example. Okay, so that distance of 200 is from the center of the circle itself to the x-axis. So I can take y3 directly as 200. But if you want to go stepwise, then y3 will be what? How will you get y3 is? Again half of the diameter, which is 25, plus below the circle you will have a distance of 175. 175 plus 25 will be again 200. So you need not do that, but some textbooks still give it, or maybe you can do it easily if you want to come below the circle stepwise, or you can use the given dimension itself to find the value of y3. So here be careful that x3 is not directly 400 by 2, but we get x3 as 150 plus r. So now I think I have summarized the values of x1, y1, x2, y2, x3, y3. The important thing in this is the circular element is a cutout section and its area, okay, pi r square by 4 or pi d square has to be taken as negative because it is a cutout section. So now let's come to our figure, let's come to our table. I am moving a bit fast now because I think after solving these many examples, okay, you will be capable of solving the examples a bit more faster. So for the rectangle, area is 400 by 500, x1 as I said directly 400 by 2, and y1 you will get it as 500 by 2. Then ax and ay. For the semicircle, area is pi r square by 2, x is 400 by 2, which is 200, and y is 500 plus 4 into r by 3 pi. Get a2x2 and a2y2. Then for the circle, the area is pi r square. Okay, so here we have to take the area negative. Okay, we have to take the area negative. Be careful with that minus sign. Then for x1 it is 150 plus 50 by 2, and y3 is directly 200. So calculate a3 into x3, a3 into y3, both will have a negative sign. So once you finish it, do the summation of areas, summation ax, summation ay. Remember, the last element is with the minus sign, so you have to subtract them. Don't add the last elements because they are with the minus sign. Then find out the location of the centroid using the regular formula x bar and y bar. So your centroid in this case lies at x bar is equal to 200.188 and y bar is equal to 331.035. Okay, so this was the first example with the cutout section. The only difference is that the area of the cutout has to be taken with the negative sign. Okay, so generally these type of questions are frequently asked, a cutout section, hence you understand them very much properly. So go through this example and try to solve it very much neatly. Thank you.